All right, here we've got a 10 kilogram block sitting on a ramp of 30 degrees, and we're applying a horizontal force of 200 newtons to that box towards the ramp. And if the coefficient of static friction between the two surfaces is 0.5, what's the magnitude of the acceleration of the block? So let's sketch out our problem here. So we got our inclined plane. Theta equals 30 degrees. We've got a mass equaling to 10 kilograms. And then we're pushing it horizontally. So we'll call that a push force equal to 200 newtons. And the question is, what is A? Well, if we draw a free body diagram, which is what we always need to do, we have the force. Sorry, that's not going to look like that. Let's draw the forces that we know will always be there. So we'll always have Fg pulling down. We'll always have Fn pointing out of the ramp. But then we have this new push force like this. And so what we need is our friction to actually act down the ramp, because it's going to oppose the motion of the push force pushing it up the ramp. So now we need to break down our Fg and our Fp into forces along the ramp. So net force X, net force Y, let me do that first. So in the X direction, it's going to equal mass times acceleration, and it's going to equal Fp in the X direction plus F friction, or actually minus F friction because it's pointed in the opposite direction. So Fp in the X direction minus force of friction. The net force in the Y direction, though, we still want to equal 0, and that's going to equal Fn minus Fp in the Y direction minus Fg in the Y direction. This also would be minus Fg in the X direction. So we got lots of pieces here. Let's find out what they all are. Fg, we know that it has, from what we've done before, a diagram like this. So Fgy and Fgx. But now we've got the push force, which is going to have a piece up the ramp like this and into the ramp like that. And if we look, that's going to be just like our diagram down below of the ramp. So we're going to have Fp, Fpx, Fpy. So we want A equals Fpx minus F friction minus Fgx all over m. A is equal to Fpx, which will be Fp cosine theta minus the normal force times the coefficient of friction minus Fgx, which we know is Fg sine theta, all divided by m. So now we need to find out what the normal force is from this expression right here. So normal force is equal to Fpy plus Fgy, which is equal to Fp, what's that, cosine theta, plus Fg sine theta. So A is equal to Fp cosine theta minus Fp cosine theta plus FG sine theta times mu k minus FG sine theta all over m. So at this point we know FP, we know theta, we know mu. The only thing we're missing is FG equals mg, which you can plug that all in, calculate a value, and that's what we'd end up with here.